5 letters were to be placed in envelopes for posting. Unfortunately, the letters were dropped down before they are put into envelopes, and we have to find the probability that at least one is in the correct envelope if we arrange them randomly. Now, we have to find probability that at least one is correctly placed, which can be also written as 1 minus probability that no one is placed correctly. No one is placed correctly, let us say. Now, so 1 minus probability of, number of favorable cases here by total number of cases. Now let us look into this number of favorable cases. Now here, favorable cases is nothing but there are 5 envelopes and we have to place 5 letters such that no letter is in the correct place. So it is nothing but dearrangements. So we know the formula of dearrangements. Dearrangements of n things can be done in n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus so on up to minus 1 power n by n factorial. This is what we do for dearrangements. Now here the value of n is nothing but 5 because we have 5 envelopes and 5 letters. So the number of favorable cases is nothing but 5 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. If I simplify, this value will be nothing but 11 by 30. Now it will be 11. Now the required probability is nothing but 1 minus favorable cases are 11. Favorable cases will be 44. If I simplify, this will be 44 by, and the total number of cases are nothing but 120, which is 5 factorial. If I simplify, it will be 19 by 30, which is nothing but option D. The given non-exact differential equation is y plus x cube y square into dy by dx is equals to 0. This can be written as y dx plus x cube y square dy is equals to 0. Now here m is nothing but y, n is nothing but x plus x cube y square. Now dou my dou y is nothing but 1, dou n by dou x will be 1 plus 3 times of x square y square. Now dou n by dou x minus dou m by dou y, 1 by m, or if you take 1 by n, the value is not in terms of only x or only y. So it is not in any standard form. So the answer is none of this because we cannot find any integrating factor here.
Z of z is equals to alpha z inverse plus beta z power minus 3 is distortionless low pass filter. Then the relationship between the alpha and beta is. Here for the distortionless, the filter phase must be a linear function of omega. That is z of e power j omega is nothing but alpha j omega plus eta e power minus j3 omega. If we take it as common, that is e power minus j2 omega alpha e power j omega plus beta e power minus j omega, means the angle of g e power j omega is nothing but minus 2 omega plus angle of alpha e power j omega beta e power minus j omega. This phase must be a constant or 0. The angle of this must be constant or 0. For that to happen, alpha equals to beta is also possible, alpha equals to minus beta is also possible. For these two possible combinations, the angle is going to be real, means that is 0, but this is the low pass filtering action, that is at omega equals to pi, magnitude of g of e power j omega equals to 0. That means 0 is equals to alpha plus beta, that is alpha equals to minus beta is the correct one. We have to choose alpha equals to minus, that is option B is correct. Let x of n be a discrete time signal. y1 of n equals to x of 2n, y2 of n is equals to x of n by 2, n even, y2 of n equals to 0, n odd. Consider the following statements. If x1 of n is periodic, then y1 of n is periodic. If x of n is periodic, then y2 of n is also periodic. If y2 of n is periodic, then x of n is periodic. See, first of all, we have to understand what do you mean by y1 of n and y2 of n. X of 2n means we are trying to compress the signal. That means we are not removing any samples at all. What we are trying to do is we are compressing the signal. That doesn't means it's not going to affect any periodicity. So if x of n is periodic, then x2 of n is also periodic. Comes to y2 of n, x of n by 2, what it will do is it introduces the one sample, that is 0 sample, in between the every two successive samples. So it's also not going to affect any period, because introduction of or removal of samples doesn't affect the periodicity. Hence all the statements are correct, and so option A is correct. If n is equals to 1 mod less than or equals to n1 and 0 mod n greater than n1, then the DTFT of x of n is written as, in this case, minus n1 to n1 e power minus j omega n. So if we solve this one, we will get sine of omega n1 plus 1 by 2 divided by sine of omega by 2. So n1 plus 1 by 2 in this case is 3 plus 1 by 2, that is 7 by 2. So it is going to be sine of 7 omega by 2 divided by sine omega by 2, which is option B.